Welcome back, Focus learners. I am absolutely thrilled to have you here for today's explainer, mostly because we're tackling something that's just, well, it's incredibly powerful and beautifully logical. We are demystifying the algebraic equations of straight lines, specifically diving deep into KSSM Form 3, Chapter 9 Mathematics. Whether you're prepping for a major exam or you just want to finally understand the hidden geometry governing the lines all around us, you are in exactly the right place. So grab your mental tool belts, because we're going to break down these concepts so clearly they'll become absolute second nature to you. Okay, let's dive right into our roadmap for today. We've got 1, the golden line equation; 2, switching equation forms; 3, points and parallel tracks; 4, crafting the exact equation; 5, where straight lines intersect; and finally, 6, summary and exam tips. Section 1, the golden line equation. Let's get right into it. So here is our absolute golden rule. Y equals mx plus c. It's basically the DNA of any straight line, and every single letter here has a very specific job. The m tells us the slope or gradient of the line, exactly how steep it is, and the c is just as crucial. It tells us the y-intercept, which is that exact spot where our line boldly crosses the vertical y-axis. Once you know M and C, you literally know everything about that line's personality. But as you probably know, exams rarely give you things neatly wrapped with a bow. How do we handle a messy equation like 3y equals negative 2x plus 12? See that 3 attached to the y? It's completely blocking our golden rule. So logically, we have to divide by 3 to get y entirely by itself. But, and this is a big but, to keep the math fair, whatever we do to the left side, we absolutely must do to the right side. So we divide everything by 3. The result effortlessly transforms back into our golden format. Y equals negative 2/3 x plus 4. Instantly, we can spot our gradient m is negative 2/3 and our y-intercept c is 4. Now, what about the special cases? What if a line has no slope at all? Or it goes straight up and down? Well, perfectly flat, horizontal lines that run parallel to the x-axis are wonderfully simple. They're just written as y equals a specific number, which we'll call h here. Conversely, perfectly vertical lines running parallel to the y-axis are simply written as x equals a specific number. No complicated gradients to worry about with these ones at all.
Moving along to Section 2, switching equation forms.
Think of this like dressing up the exact same line in 3 completely different outfits. First, you've got the general form, where x and y are grouped together on one side. Second is our familiar friend, the gradient form. But the third one, the intercept form, is just incredibly useful. It's written as x over a plus y over b equals 1. You'll definitely need to know these 3 distinct forms and how to decode what those denominators mean. In that final intercept form, the a on the bottom directly tells you the x-intercept, and the b tells you the y-intercept. Let's actually see how this builds a logical, step-by-step recipe for converting a standard equation into that clever intercept form. We start with 2x plus 3y equals 12. Now, the whole goal of the intercept form is that the right side must equal exactly 1. So how do we turn a 12 into a 1? Easy, we divide it by 12. But again, the rule of mathematical fairness applies. We have to divide everything on the left by 12 as well. After a quick simplification, we get x over 6 plus y over 4 equals 1. In just 4 quick steps, you instantly know this line crosses the x-axis at 6 and the y-axis at 4. Magic, right? All right, Section 3, points and parallel tracks. First up, let's talk about points. How do you actually prove a specific coordinate sits directly on a line without drawing a massive graph? Simple, we use substitution. Let's test point P with an x value of 2 and a y value of 8 on the line y equals 3x plus 2. We just plug the 8 into the left side for y. Then we plug the 2 into the right side for x. The right side becomes 3 times 2, which is 6, plus 2, giving us 8. The left side equals the right side perfectly. Because they balance out, we've mathematically proven that point P lies exactly on that line. If they didn't balance, well, the point would just be floating somewhere off in space. Which brings us to a really fascinating geometric question about parallel tracks. Imagine train tracks stretching out to infinity. How do we prove, using purely algebra, that 2 lines will never, ever meet? The answer is beautifully simple, and it's captured perfectly in this core mathematical truth. Straight lines that have the same gradients are parallel. That's it. If their m values, their steepness, are absolutely identical, they are gonna run side by side forever, never touching. Now listen, exam setters love to test this by hiding the gradient in a messy equation. Look at line A. It's given to us cleanly, y equals 3x plus 5. The gradient m is 3. Super easy. But line B is stuck in general form. 6x minus 2y equals 9. You cannot just look at that 6 and guess. If an exam tries to trick you with a messy second line like this, just logically rearrange it back into our y equals mx plus c blueprint. Move the 6x over, divide everything by -2, and suddenly line B reveals its true form. Y equals 3x minus 9 over 2. Look at that gradient right there. It's 3. Because both m values are exactly 3, we've definitively proven they are perfectly parallel.
Section 4. Crafting the exact equation. Okay, this right here is your ultimate 4-step survival toolkit for exams. When they ask you to literally build the equation from scratch, just follow the sequence. First, find your slope, your m. Second, pick any coordinate point that lies on the line. Third, substitute that m and those x and y coordinates right into our golden rule so you can solve for the one missing piece, the y-intercept, c. Finally, piece the whole shebang together and write out your brand new equation.
Let's watch this happen in real time. See how fluidly this works in practice when we just plug the numbers in. Say we're told the gradient is a half, and the line passes through point P at 6, 8. Following our toolkit, we write y equals mx plus c, and we plug in 8 for y, a half for m, and 6 for x. Well, a half times 6 is 3, so 8 equals 3 plus c. Basic algebra tells us c must be 5. Now we have our m and our c, we just write it out. Y equals 1/2 x plus 5. Boom! We just built an equation out of thin air. Next up, section 5, where straight lines intersect. Let's shift gears. When two non-parallel lines crash into each other, you actually have 3 trusty methods in your toolkit to find that exact crossing point. The graphical method is purely visual. You draw it out and literally point at where they cross. But let's be honest, drawing takes time and can be imprecise. So today, we're going to focus on the heavy hitters, the mathematical methods of substitution and elimination. First up is the substitution method, which is honestly exactly like a puzzle. We have 2 equations here. The trick is to take one equation and isolate a variable. In step 2, we rearrange the first equation, so y is entirely by itself. Y equals 5 minus 2x. Now that we know what y is disguised as, we take that expression and slot it directly into the second equation, where the y used to be. Suddenly, we have an equation with only x's. We solve for x, find it equals 3, and then pop that 3 back into our first rearranged equation to quickly find that y equals -1. Our intersection point? It's exactly 3, -1. Alternatively, we can use the elimination method. This always feels a bit like an algebraic magic trick to me. Looking at the exact same 2 equations, we want to scale one up so that the y parts match perfectly. If we multiply the entire first equation by 2, we get 4x plus 2y equals 10. Notice how both equations now have a 2y in them? Because they match, we can subtract the entire second equation from this new one, completely eliminating the y variable in one clean move. We're left with just 3x equals 9, meaning x is 3. Pop that back in, and again, we find y is -1. It's a completely different path, but it gets us to the exact same destination point of 3, -1. Finally, section 6, summary and exam tips. Before you face down any exam questions, keep this checklist burned in your memory. Always anchor back to your golden rule, y equals mx plus c. If you need to find the slope between 2 points, remember the gradient formula, m equals y2 minus y1 divided by x2 minus x1. Absolutely always isolate y first before you try to guess the gradient. Constantly watch your negative signs because, honestly, they are the easiest place to make a silly mistake. Keep your algebra completely fair on both sides of the equal sign. And never forget that parallel lines are just lines that share the exact same steepness, the exact same m. Well, we've reached the end of our explainer today. With the code cracked and these incredibly powerful algebraic tools firmly in your pocket, I want to leave you to ponder this. What complex, real-world problems will you decode now that you possess the ultimate blueprint to every straight line? How are you going to use this logical, unshakable foundation to solve the mysteries waiting in your next exam and the geometry of the world beyond? Thank you so much for learning with me today. Stay focused and keep exploring.